So we started by looking at these two pictures. Remember, the original is the plan that the artist made first on a piece of paper. Then the image is what happened when they took that plan, scaled it up, made it really, really big, and turned into a mural on the street. We said that these two pictures are similar to each other. And in mathematical terms, we discovered that that means when things are similar, they look the same and they have the same general shape, but the size is different. We're going to learn some new vocab today that's going to help us better describe what we mean when we say that this shape stays the same, but the size changes. Mathematicians are going to be particularly focused when they're comparing similar shapes. They're going to be particularly focused on the sides and the angles of those similar shapes. And we have a vocab word that's talking about special sides and angles, and that word is corresponding. We're going to be exploring how we can find corresponding sides and corresponding angles when we have two shapes that are similar. Another word for corresponding. You might think of, like, for example, a detective who is investigating a crime might be looking for corresponding fingerprints. What is another word for corresponding then? Another word could be matching, right? That detective is looking for the fingerprints that are matching. In a similar way, mathematicians are going to be looking for which angles and which sides match each other between the similar shapes. So when you see these two triangles, the smaller one, triangle A, B, and C, and the bigger one, triangle X, Y, and Z, first of all, we can see that those two triangles are similar. They sort of look like the same triangle, just XYZ is bigger, but the general shape is the same. So we can say those two triangles are similar. That means that they have corresponding angles and corresponding sides. So if we look over here at angle A, this is angle A right here. And if we want to find out which angle in the larger triangle corresponds, then we are going to think about, okay, this angle matches with which of these angles over here. Well, looking at it, this angle looks like it's the same as angle X up here. So we can say that angle A and angle X correspond to each other. In the same way, right down here, I see angle C. You might be recognizing, oh, angle C, that's a special angle. I know that that's 90-degree right angle. So angle C corresponds or matches with which of these angles over here? Oh, it's in the same position. It looks like a right angle again. Angle Z corresponds. So let me write that. Angle C and angle Z correspond to each other. We can do the same thing with the side lengths. Which sides match or correspond to each other between our two triangles? Well, if I'm talking about this side right here, between angle and angle C, first of all, I'm going to call that side AC. So to name a side, I'm going to use the two letters that are at either end of the side. So this is side AC. And side AC corresponds to XY, ZY, XZ. Which of those match with side AC? Side XZ looks like it's the same. It matches. So I'm going to say that side AC and side XZ correspond to each other. Let's do one more. Maybe I'm going to look at the bottom of the triangle down here. The bottom of the triangle is side CB. Side CB corresponds over here. Same side, side ZY. CB and ZY. That's how we can look between two shapes that are similar and figure out which sides and angles are corresponding. This is going to be really important as we learn more about what it means specifically for shapes to be similar and how we can compare those corresponding sides and angles.